Hi, my name is Vahan Davoudian. I'm a physical experimentalist for 34 years, and today our topic is James Clerk Maxwell, a Scottish physicist and mathematician. He was one of the best in the time. So he was one of the best, scientists, and then he was the one who discovered light is electromagnetic. And in fact, I will not only explain his life, but also great accomplishment in science and everything else. And in fact, this is my creation. I did this logo, and you can see if you click on my logo, you can go all the way, watch my 68 theories all the way from 1998, and then you can see I have the electrons, I have plasma, I have general relativity, I have Ampere's coil over here. So it's called Unique Physics Concepts, How to Promote Science. And this is Vahan Davoudian, physics experimentalist, and this is my email, vahandavoudian1948@gmail.com, and this is my YouTube channel, and you can also watch more. And James Clerk Maxwell was an amazing physicist. He was born in 1831 in Scotland, and he would like to think, take things apart. And he was also not only a good scientist, but also a good handyman. When he was 14 years old, he discovered that he can do with two pins, draw ellipse. And then he was thinking about the sun. Always the electromagnetic waves from the sun are radiated at the same speed. And he was wondering what is the speed of those electromagnetic waves are. So what he did, he calculated the ratio of electric unit field to the electric magnetic field, and he came up with this amazing number, 300,000 kilometers per second. And it just happened to be, this was so close to the speed of light, and then he deduced that light is electromagnetic. Well, of course, electromagnetic helped us a lot, and I think, in my opinion, it made the universe smaller to us because it can travel in the millions of billions of kilometers because they're self-sustaining, they create one another. So there is no way that, we can have the distance planet and everything else. The reason why they can travel in empty space, even in vacuum. And this is his picture, James Clerk Maxwell, and then you can see behind him, this is a good photo, I like it. You can see the electromagnetic wave, and this is the coil for electromagnetism, and this was with Andre Ampere. I will explain later that he was also a great scientist. And let's see, I have another thing, another poster, so I put this on. I have to mention something important. This is going to be the most comprehensive theory or the YouTube video I've ever created, because you're going to love it. The reason why, not only I describe his life and then his accomplishment, but also I had to add 3 more concepts, which was my idea. And I remember many years ago in CU Boulder and Regis University, I discussed this. They loved this and they wanted to publish. We never get a chance to do this. So those 3 things I added, I will show you here. They are breakthrough in science, and I hope you will like it. And in fact, James Clerk Maxwell was in 1860, he was 29 years old. He became a university professor at the King's College in London. And at that time, Michael Faraday was 70 years old. And then they were friends. They would see each other frequently, and then exchange views and discuss everything else. And in fact, James Clerk Maxwell always loved him because he wanted to get his line of forces or flux line, because he was getting his bachelor. Michael Faraday said, okay, you can use my idea for your bachelor for dissertation, and it happened to be so good, so he used that. And in fact, he has so many discoveries, and one of them was, Saturn ring. He also discovered the kinetic energy with one of the greatest physicists, Austrian physicist. His name was Ludwig Boltzmann. So they calculated the kinetic energy. And then at the same time, there was a French scientist, his name was Ampere. And then in 6 months of this discovery, he did his own experiment. And after that, there was another scientist, English scientist, William Sturgeon, said that if you have a coil and then you have a ferromagnetic inside, it will enhance it. But one of the most important things happened after the Maxwell was Heinrich Hertz. This was the German physicist who discovered the electromagnetic radio waves. And this happened that, he had an experiment. So whatever Maxwell predicted, it came true. In 1888, Hertz, what did? He had two globes and 1 meter apart. Then he realized if he have a high voltage on them, he can have a spark in between. And this was also another breakthrough in science, because they realized the electromagnetic wave can travel with no connection. Well, what after this, Maxwell came, because it was in old days, it was like electricity hyphen magnetism. What Maxwell did, he unified the electromagnetism. He removed that hyphen, so it wasn't electricity hyphen magnetism, it was electromagnetism. This is the very important part of my lecture, and you can see, and like I said, this is my logo. If you click on this, you can see all my theories, and this is my email. Well, of course, I explained this. And this is called Unique Physics Concept by Vahan Davoudian. And this is so important because I had to add 3 more concepts to whatever Maxwell, Andre Ampere, and Michael Faraday, and Gauss did. So this is going to be so important, so I just want you to pay attention to see what it is. Always I mentioned in my theories long time ago that, my inspiration comes from animals, insects, and nature. And in fact, this one happened to be the nature. I will explain in a minute that how the nature helped me to come up with the theory of the separation of charges. And this is an important discovery. All my observations so happened. And the first one is for the Andre Ampere. And he was the one, of course, everyone knows him. He was a famous French physicist, and he discovered, so many things. And he was the first one after that. Hans Christian Ørsted, he said that if you have electricity in a, wire, you can get magnetic field. And he was the first one who discovered the coil. Let me show you. Solenoid or coil like this, and then he was the one who discovered if you have the tightly wound, like wires like this, you more magnetism you get. Well, of course, I have to explain something. See, whenever you have a current carrying wire, you can see here, this is a current carrying wire. It doesn't matter from plus to minus or minus to plus. You can see these concentric lines. These are exactly line of forces. Well, of course, I don't want to take a lot of time. I have done this so many times with the ferromagnetic powders, and then you can see whenever you have a current carrying wire, here you can see all around concentric. And this also follows exactly like a magnet. The further you go from this current, the weaker they come. So in other words, it's inverse square law. This was his famous experiment, Andre Ampere, and he did this in 1830, and then you can see we have the minus to plus and then minus to plus, and these are two, is so famous, it's called two current carrying wires parallel. They attract each other. This baffled me so many years, and finally I got my question because everything happened in Denver, Colorado. And then one day I was having, this was the year 2000, I was having my coffee, and then I was in downtown Then this was called Confluence Park. And then I was on the bridge, and then I realized something caught my attention. It is called the South Platte River, and it was summertime, and the river was kind of quiet. It was slow, it was calm. And then I realized when I'm standing on a bridge, and then I'm looking down, the current is flowing, and all those floated things, like chalks and woods and things like that. From my perspective, they turn to the left, and then from my right perspective, they turn to the right. And then I realized this is a good inspiration for me. This flow of river is exactly like flow of electrons or flow of current. And I came home, and then I wrote my theories, which was great success. I brought this up in CU Boulder and other places. They loved it. And then finally, I had to, go ahead and publish it. And then at those days, there was no YouTube anyway. I had to make photocopy, and then I had to make DVDs. But now I'm glad now I have the YouTube video. And in fact, the theory of separation of charges was great success for me. And last time I published this was a year ago, in February 2nd, 2024. You can watch the whole film. I got almost like 25 experiments, and I explained everything with great precision. And it's 1 hour and 15 minutes, so you can watch that. So the reason why these two wires attract each other because of theory of separation of charges. And I'm glad I discovered something that I have never seen in any books or any, textbooks or any, even, YouTube videos or university lectures. So the reason why, see, we have north and south, north and south. So I did with this compass, and then I did with so many other things I will show you. Every time you have a current flowing in this, well, of course, I have to mention we're talking about DC current, not the AC. So you can have north and south, north and south. And it doesn't matter if you rotate this wire, even if it's 1 millimeter, 360 is going to be always. The reason why charges are separated. So the reason why these two wires attract each other, because see, we have seen north-south, we have south-north, north-south, south-north. They attract each other. Well, I have to mention something. It's a little bit complicated, this part. You have to go to the subatomic part in order to get this. Because we have a dipole. Electric dipole is so important. We have the south and north, or plus and minus, and they're separated, and it's like a subatomic. And people a long time ago, they had no idea there's a dipole. But in 1986, when the two Swiss, scientists discovered, the scanning tunneling microscope in 1986, they solved the problem. You could even take a picture of the atoms, cesium atom, so many atoms, which is like 3 or 4 nanometers. It's unimaginable how small it is. And the magnification for scanning tunneling microscope is 10 million times. So this solved the problem, and we have a dipole. And in fact, electron itself has a dipole magnetic moment. And can you believe electron, the subatomic particle, which is so small, compared to the nucleus and proton and neutron, they have a dipole moment. The reason why they have electron is not like a magnet, they have a loop, because electron, that dipole exists intrinsically. So intrinsic is a good word. It means it naturally exists. So every time we change the current, if I have two wires like this, then this one goes from positive to negative. What happened? They repel each other. The reason why? The dipoles orientation is reversed in respect to the flow of current. That's the reason why. If I have a coil like this, by the way, this is my creation, this is my idea, because I use this for my, this little coil has 1,000 Gauss. So if I have like minus plus, and if I have a magnet over here, it shows south. If I turn this way, it's going to be north. Even though I'm not changing the flow of current, but like I said, I'm reversing the dipole's orientation. And this is the one we call it Gauss meter. It's a DC Gauss meter. Let me show you here, close up. This is fantastic device. I've had this for 24 years, and God knows all this experiment, you have seen all these 67 theories. I have some of them are for electromagnetism and some other things. I use Gauss because the precision is almost 99%, and this can calculate almost, 99,000 Gauss. And that was the one, I'm going to discuss later, German scientists, which we have so many ideas. He had the good ideas. So always I use this Gauss meter. So you can see this is the reason why the electrons are reversing their, dipoles. And in fact, you can see here we have the electromagnetic wave. You can see this part, and then you can see it's like an alternating current. Up, down, and this is the electromagnetic field. And one of the great things about the electromagnetic waves, they are perpendicular to one another. So you can see the electromagnetic field. And it's like a chain. But the best example is if I have a huge screw, if I rotate it like this, it doesn't matter clockwise or counterclockwise, so positive becomes negative, negative becomes positive, or north becomes south, south becomes north. That is the best example. You can see this is like a screw, but you have to screw it like this, you have to turn it like this, so you can have electromagnetic wave. That is the reason why they can go and sustain one another and then travel in empty space. Well, of course, this is a comparison, and this is the sketch by James Clerk Maxwell, and when he was getting his bachelor, and then he sent this to Michael Faraday. He said, Michael Faraday, I love your line of forces. He would call it flux line or line of forces. They're the same thing. And he said, Michael Faraday, these are exactly the same thing happened in space. And imagine when you compare with general relativity, Albert Einstein, the similarities are shocking. That is amazing. These are exactly the same thing. So the Earth is causing the fabric of the universe to dent, and the moon is falling in that, thing. So this is exactly the same thing. Maxwell did, he said, single electric field will disturb the uniform magnetic field. You can see how similar they are. Or probably Albert Einstein got the inspiration of the general relativity from the Maxwell, because this sketch is so many. Well, of course, he has more sketches. And you can see, instead of electric field, this is replaced by the mass. In fact, Maxwell has 4 equations, and I have seen so many videos, and with no exception, 99% of these scientists or people, right off the bat, they go to Maxwell's equation. They don't talk about his life, his accomplishment and some other things. Well, of course, it's so important, but there's a misconception about this. I have to clarify this. These 4 equations, we have 3 other people involved. So what Maxwell did, he unified everything. Well, of course, there's no doubt he did a correction for the ampere. He also helped, Michael Faraday, because unfortunately he didn't have high education, so he was not good in formula. So he helped him, and then they would exchange views all the time. And the first one is for the Gauss for the electricity, and this was a German physicist and mathematician. And as a matter of fact, he was the only one who discovered that the Earth's magnetic field is not from outside, it's from inside. There was a debate, and finally he proved that. And his first law is the Gauss law for the electricity. And he can see, always he said that, any charges in a closed circuit, I have to show you something. This is called a loop. So you can see this might be like at least 40 or 50 loop. So you can see it's a closed circuit. Why do we call it loop or turn? I don't know what they call this loop. So both Michael Faraday and Andre Ampere used single loop. So was the Gauss. So in a single loop, the charges are exactly the same. So, and his second one is so important. He said there is no monopole. And I have to mention why, because if you have a magnet, a small magnet, it doesn't matter, we have north-south. And if you cut that magnet in two, if you cut that in thousands and millions, always you have north-south. The reason why, a few minutes ago I said, it goes all the way to dipoles. And in fact, at that time, you know, they realized that a magnet always has two poles. And he proved that, and he said the flux going from the, toward the south pole is exactly equal to the flux going to the north pole, and the net flux is always zero. And the third one was Michael Faraday, one of the greatest minds in the history of mankind. And then he discovered laws of induction, and then he also had invented the first electric motor. Let me show you. This induction changed our life forever. If you have a coil like this, and you have a magnet like this, it doesn't matter if you push and pull this coil in the magnet, and imagine if it's connected to multimeter, it shows going to the left or right. And it doesn't matter, as long as you have the relative motion between magnet and the coil, you will get electricity. But it depends on how many turns you have here and how fast they move. There's so many factors, but overall you can see your multimeter is going from left to right, or if you have the new one, it goes to plus to minus. But this is so important. When I pull this in, it goes from one way. When I pull this out, it goes the other way. And in fact, poor Michael Faraday had no idea that he discovered the alternating current, and nobody mentioned that to him. And I have never seen in any books or any lectures. He discovered the, electrical current, or in other words, alternating current. So we didn't have to wait another 60 years for Mr. Nikola Tesla. Well, of course, he was genius. He discovered the changing magnetic field. We get the alternating current, and then you can have induction. You cannot have induction with a DC. It must be changing magnetic field, and this is the principle. And Mr. Maxwell had so many inventions, and this is one of those. And I remember when I was in high school, we used to do that. So we have the primary colors. So we have the red, green, and blue. If you turn this, you're going to get white color. Well, of course, I have to mention it's not 100% right. It's a little bit off, white. But these are the basic component. Well, of course, like a month and a half ago, I did this, and then people loved it, and then they emailed me a lot. I had to use the electric motor, and 3,000 RPM, this becomes white. And then you have no idea that, this one is green, this is blue, but it shows the white. And these are my creation. This is my design. These are my coil, and then I use this for my electric motors. You can watch this, and then it's called the New Concept in DC by Vahan Davudyan. This was published two years ago. You can see this little coil, I would say probably 3 centimeters across, has 1,000 Gauss. This one has 1,200 Gauss. This one is much larger. And if I have like 12 volts, it'll be, if you have 18 volts, it'll be more. If I have 20 volts, it'll be more. So it's the function of current. The more current you have, the more magnetism you have. So Faraday realized that changing magnetic field will cause induction, and this was great. And then the last one was Andre Ampere. Well, of course, there is a, there is a story behind this. In 1820, Hans Christian Ørsted, Dutch physicist, he had a science lab, and then there was a compass on the table, and then there was some wires, and then it was not turned on, the compass was on the table, and then he realized the compass is pointing north and south exactly the way they should do. And then they had some wires, and they were doing some experiment. One of the students turned on the wire by accident. They didn't want to, and then Hans Christian Ørsted realized that, turned on the wire, it just, everything changes, and then it's a reaction between electricity and magnetism, and then the compass changed. So in other words, he realized that the compass, like this, is exactly perpendicular to the flow of current. Then he realized there is a connection between electricity and magnetism. It doesn't matter from left to right or positive to negative, because the point, but it's always perpendicular. And this was a great moment in the history of mankind or history of science. And then Hans Christian Ørsted deduced that, there's a connection between electricity and magnetism. And before there is electricity hyphen magnetism, and then he says electromagnetism. And he had to wait 3 months and then get this pamphlet, and then he translated everything, and the whole world was shocked. This was amazing discovery, and there was electromagnetism. And Maxwell came, he refined everything. He said, yeah, it's like a coin and two, like a coin. It's head and tail, and then it doesn't matter how you turn it, always you have positive, negative, or north and south. And that is exactly the same force. And in 1860, he came up with the electromagnetic waves. Like I said, he made the universe smaller for us, because that was the most important discovery of the mankind. Well, of course, there was something missing here. Andre Ampere said, you know what? Anytime you have in a closed loop, show you closed loop, the magnetic field is exactly proportional to the current. So it's a function of current. The more current you have, the more. But there was something missing. They had no idea why the electromagnetic wave, they travel in space endlessly. But Maxwell had to do the correction, which happened to be the most important correction for the Ampere's law. Ampere said when you have electricity in a conductor or something like that, you get what? Magnetic field. Maxwell said we have to add one more thing. Not only you can get magnetic field with electricity, but also changing electric field will cause magnetic field. And this was amazing discovery. And then even he changed, Ampere's formulas. That's why they call it, correction for the amperes. And this solved so many problems. I had to think about this for so many years, and finally I come up with the answer. The reason why they are self-sustaining, the electromagnetic is self-sustaining. The reason why the electric field also changes. It becomes magnetic field. So it's changing endlessly, and like I said a few minutes ago, it's like a screw. It doesn't matter how, it is like a chain, positive, negative. It keeps changing, and that it can travel all the way in the space. Now, this is the one I explained a few minutes ago, but this one has a better pictures, and this is the sketch with the Maxwell, and then you can see it's much larger. And this is the one, the electric field is disturbed by the uniform magnetic field, and then you can see it's Albert Einstein general relativity. And then what I did, this is my analogy, or I had to compare the, Maxwell sketch with general relativity, and you can see the similarities. This is the electric field is disturbing the uniform magnetic field, and then the sun, see, it's disturbing, and the earth is here. So this is another one. We have the earth and the moon, but this was my idea that, it's so similar. I have one more. One of the greatest things about this electromagnetic wave, it is so versatile. It's so indispensable. And like I said a few minutes ago, when Hertz discovered the radio waves, he just finished this chapter. So we don't have any more, so all those 4 formulas, you can have all the electromagnetism. But I have to explain something here. So we have radio waves, you have microwaves, we have infrared, and then we have visible light, and then we have ultraviolet, we have X-ray and gamma rays. You can see how versatile it is. Each part is used for a special purpose. Radio waves are so huge, and amazingly, this electromagnetic wave is so amazing. I mean, the stretching this is exactly proportional to the compression. You see the gamma rays, and then how amazing it is. Proportional, it is 100%. And you can see here, it's like an alternating current, up, down. So electric field, magnetic field. Electric field, magnetic field. See, they produce each other endlessly, and go in an empty vacuum. And I'm glad, I covered everything. I'm not exaggerating. It will be 1 million view, maybe 10,000. But you guys realize how good I explained and how good I just, scrutinize everything, how good I analyzed everything. And I'm hoping you guys will take this into the consideration, and then you can, subscribe, or if you like the video, you can send me email, or you can have your comment. But like I said, Maxwell has always been my favorite scientist, and I admire him, what he did. But unfortunately, the poor man died at age 49 of the cancer, and then he could have come up with so many other things. Because when I compare, say, Isaac Newton and Maxwell, these two scientists were two of the best in the world. Thanks a lot for watching, and I hope you guys enjoyed this video. If you like it, you can subscribe it and give thumbs up. Thanks a lot for watching.